All right, level 3 is where the cross multiplying and the setting up gets a little bit trickier, but the process is going to be the same. So in number 5A, what we're going to do is still draw that triangle the same way that we have been. It's a 45, 45, 90 triangle because it's got the 45 degrees. I know that last angle is going to be 45 as well. So this is 45, this is 45, this is going to be 1, 1, square root 2. So to find the missing sides, this is going to be x, this is going to be y. To find out x, I'm going to use x over 1 equals 10 root 6 over, it's going to be 1 as well. Okay, 10 root 6 is going to correspond to this 1 over here, and the x and the 1. That's why I took that. So cross multiplying, since they're both over 1, doesn't really cause us a problem, or shouldn't, because multiplying by 1 doesn't really do anything. So x is nice and it equals 10 root 6. Okay, obviously because it's a 45, 45, 90, the legs are going to be congruent. So if you forgot that, again, you can always set these equations up just to make sure. So again, let's go ahead and do the y now. We got 10 root 6 over 1 equals y over root 2. Okay, so here's where things become a little bit challenging. We're still going to cross multiply. So when we cross multiply with the root 2 and the 10 root 6, remember you multiply your roots together. You don't multiply root and number. You've got 10 root 6 times root 2 equals 1 times y, which is just y. Okay, you can multiply the roots together and say 10 root 12 equals y. The last thing that you got to do is simplify the radical. So we're going to go ahead and break this down into 4 and 3, 2 and 2. So the 2's, it has a pair, it can come out. We're going to multiply it with the 10 that's already outside. The 3 is something that has to stay in the square root. So it'll be 20 root 3 as your final answer for y. Oh, I can write today. Equals y. Okay, so that's why this is a level 3. The math becomes a little bit more tricky with the square roots in it. All right, let's take a look at B. B looks like another 45, 45, 90 triangle, so I'm going to redraw this triangle again. This is a 1, 1, square root 2, because here's my right angle, 45 and 45. So again, I'm going to go ahead and find x, and the other side's going to be x as well, because it's going to be an isosceles triangle. So I'm going to have x over 1 equals 14 over root 2. So I cross multiply. 14 times 1 is 14. X times root 2 is root 2 times x. Then to solve for x, I'm going to go ahead and divide by root 2. And here's where you got to remember, again, this is why it's a level 3, is because I can't leave 14 square root 2 as is. There's a root in the denominator. That's not okay. What we need to do is we need to rationalize it. And we need to, that means multiplying both top and bottom by the root in the denominator. So I'm going to go ahead and multiply by root 2 over root 2. This is going to be 14 root 2 over the square root of 4. And the square root of 4 is just 2. So this equals 14 square root 2 over 2. You're almost done. 14 over 2 reduces to 7. So x is just going to equal 7 square root 2. All right. So those are part of level 3s with 45, 45, 90s. Now let's take a look at some 30, 60, 90s. So in letter C and D, we've got 30, 60, 90s. Let's go ahead and look at C first. So I'm going to go ahead and redraw my triangle, putting the 30 and the right angle and then the 60. So across from the 30, this is probably the hardest part, is labeling your triangle. But by now, I hope that we're pretty good at it. So I've got 1, 2, root 3, finding x and y. So now I've got to find both sides here. So go ahead and find x first. So I'll have x over root 3 equals 10 root 3 over 2. So this looks really gross, but it's actually going to come out nice. So I'll multiply 2 times x and root 3 times 10 root 3. So I'm going to have 2x And then remember 10 root 3 times root 3 is going to be 10 square root 9 because I multiplied the 3's together. And then simplifying the 9, the square root of 9 is 3, so I'll have 2x to equal 10 times 3, be 30. And then if I divide both sides by 2, x will equal 15. So there's example 1 with finding x. Now let's go ahead and find y the same way. I'll do y over 1 equals 10 root 3 over 2. Again, cross multiplying, this one's a little bit easier. We'll have 2y equals 10 root 3, and then I'll divide both sides by 2. Numbers on the outside I can simplify into 5 root 3. Okay, and there's example number 1. So let's go ahead and move on to example D. Same way, now we're given a different side, so I'll go ahead and redraw a triangle again. Okay, whoops, this is not 3. I don't want to label that 3 just yet. Across from the 30 is 1, across from the hypotenuse is 2, and this is root 3. Alright, so now we've got x and y. Let's label the last one x and the hypotenuse y. So let's go ahead and find x first. We'll take x over 1 equals 3 over root 3. Okay, again, we're lining up corresponding sides. So x and 1, root 3 and 3. Same spot in the triangle, but on different triangles, makes it proportional, just like in 7.2. So we've got root 3, cross multiplying, we got x root 3 equals 3. I'm going to divide by root 3, and something should be going off in your head saying I need to rationalize this because I can't have a root in the denominator. So I'm going to multiply both top and bottom by the square root of 3. So it's going to be 3 root 3 over root 9, which simplifies into 3 and 3. So this is 3 root 3 over 3, which will just equal the square root of 3. So that's x. And now let's go ahead and find y. So I'll take y over 2 equals, and you can pick any side here. Both of them are going to have a root in it. Doesn't matter. So I'm going to take 3 over root 3. Okay, let's go ahead and cross multiply here. Did I do that right? Y over 2, 3 over root 3. Yep, okay, so cross multiply, I got 6 equals root 3 times y. And then I'm going to divide both sides by root 3. Again, since I'm dividing by root 3, I'm going to have to rationalize this. So I'm going to multiply both top and bottom by root 3. So this is going to be 6 root 3 over square root of 9. Square root of 9 is just 3. So once again, these numbers on the outside, I can simplify. 6 divided by 3 is 2. So our final answer for y is going to be 2 root 3. Alright, so again, same process. The math just gets a little bit trickier when it comes time to cross multiplying, and then we've got to rationalize sometimes as well. Okay, determine the area of ABC. So again, area, what I need to do is I need to find the base, and then I need to find the height. And if I look at this triangle, I notice that I have 2 congruent sides, which means that that one's going to be 8 as well. I also notice that I have 45-degree angles here, which makes this a 45-degree angle up there as well, and this one a 45-degree angle on that side as well too, because these are the big triangles, isosceles triangles, so all angles are going to be 45 degrees. Okay, so I've got to find the base and I got to find the height. There's a bunch of different ways that we can go ahead and attack this problem. All of them are correct as long as your math is good. What I want to point out to you, one way that you could do this, if you look at the whole big triangle ABC, You notice that that is also a right triangle because you've got two 45-degree angles here. That's going to make it a right triangle because 45 plus 45 is 90. So the big triangle is a right triangle, and you've got two sides of this right triangle. You can do the Pythagorean theorem to find out what AC is. I think that's our easiest option here, so that's the option I'm going to take. So I'm going to have 8 squared plus 8 squared equals C squared. It's going to be 64 plus 64 equals C squared. And this is going to be 128. And then this is going to simplify into, once I square root this, I'll break it down and it's going to be 8 root 2. Okay, you could have found that by looking at each individual triangle and doing our proportions like we've been doing. You can definitely do that. I just saw an opportunity to use the Pythagorean theorem, so I wanted to use that. So this whole side of AC is 8 root 2. Okay, so this makes each side here 4 root 2. All right, now the only last thing I got to do is I got to find this height here. So if I look at each individual triangle, I've got 45, 45, 90s, and that's what I'm going to use. Again, I could use Pythagorean theorem, but I'm going to use right triangle trig to find this, just because that's what we're learning this week. So I want to practice it a little bit more. So I'm trying to find that last leg. Actually, you know what? We don't even have to do right triangle trig, because if this is 45 degrees and this other angle is 45 degrees, each little triangle is a right triangle that's isosceles. So both the legs are going to be the same. So the height is going to be 4 root 2 as well. Okay. Again, if you didn't recognize that, you can always, always, always do right triangle trig with your 45, 45, 90s or 30, 60, 90s. It's just what you recognize. So now that I have the height and I have the whole base, I can find the area of the triangle. So I'm going to take the base, 8 root 2, times the height, 4 root 2, and I'm going to divide this by 2. So 8 times 4 is 32. Square root 2 times square root 2 is square root 4. The square root of 4 is just 2, so I'll have 32 times 2, which is 64, over 2, which equals 32. So there's the area of the triangle. Once again, you could have found the area of this triangle in several different ways. What we noticed is that we had isosceles triangles, and since they were isosceles triangles and right triangles, we can find them in a bunch of different ways. You can use right triangle trig when you have 45, 45, 90s. You can use Pythagorean theorems, especially because we have right triangles. Just make sure that you're keeping everything in exact form.